We've all heard the phrase, the silence of space. But what if I told you that popular saying is completely wrong? Prepare to have your mind blown as we shatter everything you thought you knew about sound beyond Earth's atmosphere and uncover the surprising truth about cosmic acoustics. Now, before you jump into the comments, let's be clear. If you were floating in space without a helmet, which I absolutely do not recommend, you wouldn't hear a thing. That part is true. Sound, as we experience it here on Earth, is a mechanical wave. It needs a medium like air, water, or a solid to travel. It works by vibrating the particles of that medium, which then vibrate the particles next to them, creating a chain reaction that eventually reaches our eardrums. Space is a near-perfect vacuum. There are so few particles, they're too far apart to bump into each other and carry a sound wave. So, in that sense, space is silent. That's the science we learn in school, and it's the reason why in movies you often see explosions in space happen in complete silence. But that's where the story usually ends, and it's also where our real journey begins. To say space is silent is a massive oversimplification while you can't hear sound in the traditional way. Space is absolutely buzzing with information that we can translate into sound. This process is called data sonification. Think of it like this. Scientists collect all sorts of data from space: radio waves, plasma waves, electromagnetic fields, things our ears can't detect. They then assign pitches and tones to this data, essentially turning it into a symphony of the cosmos. This isn't just for fun. It allows scientists to hear patterns and events that they might miss just by looking at charts and graphs. It's a whole new way of experiencing the universe. So, what have we heard? Oh, you are in for a treat. NASA has released some absolutely mind-bending recordings. Let's start with our own solar system. Voyager 1, as it traveled through the interstellar medium, detected vibrations in the super-thin gas out there. When sonified, it sounds like a low, humming drone, almost like a celestial chant. It's the sound of the very fabric of space vibrating. Imagine that the space between stars isn't empty and silent. It's singing a constant low-frequency song. Then there are the planets. Each one has its own unique acoustic signature. Jupiter, the gas giant king, is a hotbed of activity. Its powerful magnetic field traps charged particles, creating intense plasma waves. When NASA's Juno spacecraft flew through these regions and its data was converted to sound, the result was an eerie sci-fi collection of whistles, chirps, and shrieks. It sounds like something straight out of a Hollywood blockbuster, but it's completely real. It's the sound of auroras 1,000 times more powerful than our own northern lights. And Saturn. Its rings aren't just a visual spectacle. The Cassini spacecraft found that the icy particles in the rings and the plasma environment around them interact in complex ways. The sonified data reveals a surprisingly chaotic yet rhythmic soundscape. You can hear pops and crackles as dust particles hit the spacecraft, mixed with a chorus of whistling waves. It's like listening to a cosmic rainstorm, a symphony of tiny collisions happening on a planetary scale. Even our own planet has a soundtrack. Earth is constantly emitting radio waves, often called whistlers, which are generated by lightning strikes. These signals travel along our planet's magnetic field lines out into space and back. When converted to sound, they create descending musical tones. It's the sound of Earth's own heartbeat, a pulse of energy echoing through our cosmic neighborhood. But the most profound and perhaps most famous cosmic sound is the one that comes from the very beginning of time itself, the cosmic microwave background, or CMB. This is the faint afterglow of the Big Bang, a radiation that fills the entire universe. When cosmologists at the Planck Space Telescope project mapped this radiation, they found tiny temperature fluctuations. They took this map, this baby picture of the universe, and sonified it. The result is a deep, rumbling, almost guttural sound. It's a recording that's 13.8 billion years in the making. What you are hearing is the amplified sound of the universe when it was just 380,000 years old, a hot, dense soup of particles just beginning to form the first atoms. It is, quite literally, the sound of creation. Let us go from the biggest sound in the universe to one of the most terrifying, the sound of a black hole. In 2003, astronomers studying the Perseus galaxy cluster discovered something incredible. This cluster is filled with a massive cloud of hot gas, and right at its center is a supermassive black hole. They noticed ripples, or pressure waves, propagating through this gas, emanating from the black hole. These are, for all intents and purposes, sound waves. Real, actual sound waves traveling through a medium, in this case, the galaxy cluster's gas. The problem is, the pitch is incredibly low. It's about 57 octaves below middle C, a frequency so low that it's completely inaudible to human ears. Its period, or the time between one wave crest and the next, is about 10 million years. Recently, NASA scaled this sound up, raising it by quadrillions of times, to bring it into the range of human hearing. The result is a haunting, deep, moaning sound. It's the sound of a supermassive black hole's activity echoing across hundreds of thousands of light years. It's a chilling reminder of the immense power lurking in the centers of galaxies. So, why does any of this matter? Beyond just being incredibly cool, Sonification is a powerful scientific tool. It helps researchers identify subtle patterns and changes in data that might otherwise be missed. By listening to the shifting frequencies of plasma waves around Jupiter, scientists can better understand its magnetic field. By hearing the echoes of the Big Bang, cosmologists can refine their models of the early universe. It adds another dimension to our perception, allowing us to explore the cosmos not just with our eyes, but with our ears as well. It's a bridge between the abstract data on a screen and our human intuition. It completely changes our perception of space, doesn't it? It's not a silent, empty void. It's a dynamic, active place filled with energy, waves, and vibrations. It's a vast cosmic orchestra playing a symphony of physics that spans billions of years and unimaginable distances. From the gentle hum of interstellar space to the shrieks of Jupiter's auroras and the deep moan of a black hole, the universe is anything but silent. You just have to know how to listen. The next time you look up at the night sky, remember that it's not a silent movie. It's a full-blown concert, and we're just now learning how to tune into the music. Thank you so much for joining me on this auditory journey through the cosmos. I hope it's changed the way you think about the final frontier. If you enjoyed this and want to explore more mind-blowing science, please hit that like button and subscribe to the channel. It really helps us continue to make content like this. Let me know in the comments which cosmic sound you found the most fascinating. Until next time, keep looking up.